So the next topic is DES analysis. So it says that the critics have used a strong magnifier to analyze DES over time, and a number of tests have been done to measure the strength of some desired properties in a block cipher. Okay, so for finding out or for checking the strength of DES, these tests have been done by the critics uh, uh, over this DES over for checking out its performance. So the DES elements have gone through scrutinies to see if they have met the established criteria or not. So we will be discussing these topics in this section. First, we'll be discussing the properties of DES, that what kind of properties should be achieved by a good encryption algorithm, and does DES achieve those properties or not? That we'll have to check. Then we'll discuss this its design criteria, wherein we'll be discussing the same thing, these S boxes and S boxes, P boxes, and the rounds. So we'll just briefly discuss this section. Then we'll be discussing about DES weaknesses. Right. So these are the topics which we are going to discuss today. So these two properties are desired, from any of the encryption algorithm, which are called avalanche effect and completeness. So avalanche effect and this completeness effect and diffusion and confusion, all these four things are related to each other. Okay, so diffusion and confusion we have already covered, wherein I told you that diffusion is all about hiding the relationship between the plain text and the ciphertext, and confusion is about hiding the relationship between key and the ciphertext. Okay, so avalanche effect, it is the desirable property of any encryption algorithm. So where a change of one input or the plain text bit or the key bit results in changing approx half or more output bits. That means if you change one bit in the plain text or one bit in the key, then approximately half or more bits in the ciphertext must be changed. And DES, we can say that the performance of DES is such that it exhibits strong avalanche effect, right? So in that sense, we can say that DES is a good algorithm, right? So to check this avalanche effect in DES, we are having this example, which is giving you this value of plain text, which is all 0. Okay, with this key, the ciphertext we are getting is this one. Okay, now if we change this one bit only in the plain text, okay, so the rest of the bits are 0 and only one bit we have changed, so we can see that there is a huge effect on the on the value of ciphertext, right? So that we can see from here, and the key value is same over here. Okay, so that is why we can say that DES exhibits strong avalanche effect, right? So that is about avalanche, and there is one more thing that this table tells you that how many bits are changed in each round of the DES, right? So here we can see that in round 1 there is only 1 bit difference, in round 2 there is 6 bit difference, and in round 3 there is 20 difference in 20 bits, and so on. Okay, so at the last round, in the 16th round, in total, the 29 bits are changed in the ciphertext. Okay, if we change one bit in the plain text, so it says that changing approximately 1.5% of the plain text, it creates a change of approximately 45% in the ciphertext, right? So there is, after 16 round, there is a change in 29 bits of the ciphertext. Okay, then comes this completeness effect, which means that each bit of the ciphertext needs to depend on many bits of the plain text. This is of many bits of the plain text. So the diffusion and confusion produced by D boxes and S boxes in DES show very strong completeness effect. So the idea of confusion and diffusion, that is, again hiding the relationship between the plain text and key and the ciphertext. So since we have added these P boxes and S boxes, due to which this DES exhibit this diffusion and confusion. So as a result, we get this completeness effect also, right? So all these two properties, this DES is satisfying. Okay, so all in all, we can say that DES is it performs very good, right? Next is this design criteria. So, that is again the same thing, because of the inclusion of S boxes, P boxes, and a number of rounds, we get this confusion, diffusion, and the performance of DES is enhanced, right? So that is about design. Okay, because we have discussed its design in detail, so that is why we are not discussing it over here again and again. Now we need to talk about the DES weaknesses, right? So what it says, during the last few years, critics have found some weaknesses in DES. So these weaknesses are in its design and in the key. Okay, so when we talk about its design, then these S boxes and P boxes are discussed. And when we talk about key, then we discuss the size of key and a number of types of keys which we encounter when we generate keys for implementing DES. Okay, so these are kind of keys which could be generated when we use DES for encryption purpose. So these keys are called weak keys, semi-weak keys, and possible weak keys, right? So we will be discussing these weaknesses in key for DES, right? So the initial point in this is key size. Okay, so first we will be discussing about key size, because I told you when we started discussing DES, I told you about that Lucifer algorithm which used 128-bit key. Okay, so at that time as well, I told you that since DES was using 56-bit key, so it was criticized, right? So that is the thing again over here. After it's uh, after publishing, or after making its use, the same point was raised again, that the key size is very small. Okay, and the critics believe that this is the most serious weakness of DES, right? Why? Because a brute force attack needs to check for 2 raised to 56 keys only. Okay, so if we talk about the previous times, then this checking of these 2 raised to 56 keys using a brute force attack, it was difficult. But nowadays, with the available technology, it is very much possible to check 1 million keys per second. Okay, so which means that we need more than we need more than 2000 years to do a brute force attack on DES with a computer which has only one processor. But nowadays we are having machines which could handle multiple processor, for parallel processing, right? So if we use a computer with a million chips, which supports, which as a result support parallel processing, then we can test the whole key domain, which is this 2 raised to 56. We can check this whole key domain in approximately 20 hours, right? So initially, for the computer with the one processor, it was taking a huge number of years, but nowadays the same thing can be done in 20 hours, right? So that is with time, since the price has dropped rapidly for these kind of machines. So these number of keys, they can be cracked using simply this brute force attack. Okay, so the solution for this problem is, to use, or to increase the size of key. So for increasing the size of key but using the same process or the same structure, we can go for double DES, which is represented as 2DES, which has two keys of 56 plus 56, which makes 112 bits. Or we can also use this triple DES, which we represent as 3DES, which uses three keys. Okay, so in total it will be using 168 bits, 8 bit key, right? So as we increase the size of key, then we can say that the security of the algorithm will also increase, right? But right now we are talking about the DES, which uses only 56-bit key. So we will be discussing these key types, which we can encounter, these types of key we can encounter while making use of DES for encrypting any message. Okay, so we'll be discussing these types of keys now, what are these keys and how do they affect the whole encryption process. So first is weak keys. So we have these four keys which are called weak keys. And when do we call a key as weak key? When after we drop the parity bit, if the key consists only zeros, all of the zeros, or all the ones, or half zeros and half ones, okay, then we call that key as weak key. I'll show you the example as well. So these are the examples of weak key, right? This is the key before parity drop, that means this is a 64-bit key, and this is the actual 56-bit key which we will actually use, right? So here you can see either this key is having all values as 0 or as 1 or half zeros or half ones. Okay, so we call these kind of keys as weak keys, right? So now what is the disadvantage of using these weak keys in the DES? Now after two encryption with the same key, the original plain text block is created. So here we can see that this is the key, okay, and this is the plain text. This ciphertext we are getting. Now if we encrypt it again, if we apply the same process again on this ciphertext, right, this one, so this becomes the plain text now, and the key is same. So the ciphertext we get over here is same as the initial plain text, as this one, right? So that is the problem with the weak keys. So after two encryptions we get the original plain text block. So what is the problem with this is, so what happens if any attacker if it tries to find out the value of ciphertext or value of key, then it can easily find out its value. Okay, now how does it do that? That because the attacker can easily try that if it tries to intercept the ciphertext, and after two encryptions, if it gets the same ciphertext, sorry, the value of ciphertext as the initial plain text. So what does it mean? That means the attacker has found the right key. Okay, so it need not to perform all the 16 rounds. Only after two encryptions it knows that what is the value of key, right? So that is the disadvantage of using weak keys. Okay, so that is the process of double encryption, which is which tells you the disadvantage of weak key. So herein we have the 64-bit text. So once we we will be encrypting the same message two times, and as a result we'll be getting the same plain text, right? Which is over here, right? Okay, next comes the semi weak key. Now, for semi-weak keys, we have six key pairs, which we call as semi-weak keys. So they create only two different round keys. So we have 16 rounds, and for those 16 rounds, only two keys will be generated for after using these key pairs. These key pairs are in 64-bit without dropping the parity bit. Okay, so now what does it mean that two different round keys are generated? And now for 16 rounds, if two different keys are generated, that means each key will be using 8 times, right? So how is it done? You can see over here that this is one key, okay? This is another key. So these are being repeated again and again, okay? And this value and all these values, they are again same. Okay, so actually we are having only two keys, right? And these two keys are being used again and again, right? And one more thing is there, that the key which we are using in round 1 is being used in round 16 at the decrypting end. Okay, then the key which we are using in round 2 is being used in round 15. Okay, so the order is in reverse at the decrypting end, right? So this key which is at round 16, that is the same key at round 1. So only two keys are there. If we if we by chance create a key from from these semi weak keys, okay, which are 12 in total, because we have 6 key pairs. So 4 weak keys we have, and 12 semi weak keys we have, right? This is the diagram for semi-weak keys, right? So only two keys will be used, this K1 and K2. The same keys will be used again and again. Then comes the possible weak keys. So there are 48 keys which we call as possible weak keys. Okay, so this key creates only 4 distinct round keys. So the 16 round keys are divided into 4 groups, and each group is made up of 4 equal round keys. Now for semi-weak keys we had only two different keys. In possible weak keys we have only 4 different keys. Okay, so these 4 different keys will be using for 16 rounds. So each key we will be using 4 times, right? So I'll show you the example. Okay, its example is not given. Okay, so in total we have these 48 possible weak keys. So these kind of keys we can have while dealing with DES. But the possibility of choosing any key from weak key, semi-weak key and possible weak key is very small, right? So we can see from this example that what is the probability of randomly selecting a weak or a semi-weak or a possible weak key. Right, so it says that DES has a key domain of 2 raised to 56 keys. So the total number of the keys which are a weak key, which is 4, okay. Semi-weak keys are 12 in number, and possible weak keys are 48 in number, right? So in total, we have the 64 keys, okay, which are weak, semi-weak or possible weak keys. So the probability of choosing one of these 64 keys out of 2 raised to 56 keys is 8.8 into 10 raised to minus 16, which is almost impossible. But if it happens, then it the whole process, the whole encryption process, it becomes prone to the attacks, right? So this is all about the the topics which we have discussed today. This is all about the DES analysis, wherein we have discussed its properties, which covered the avalanche effect and the completeness effect. And then we discussed its design criteria, which includes the S boxes, P boxes, and the number of rounds. Then we discussed DES weaknesses. Okay, so this weakness of DES, wherein we mainly focused on the size of key, it actually, initially it was the strength of DES. But if we talk in regard of today's time, then that, so presently it has become the weakness with the advancement in the technologies, right? So in weaknesses, we mainly focused on the key, which is the main the soft part of DES, wherein the attacker could attack, right? So the solution for coping up with this kind of weakness, which is because of the key size, is making use of double DES or triple DES. So in the coming class, we'll be discussing these two type of DES as well, okay, wherein in double DES we'll be repeating the whole process of DES 2 times, and in triple DES we'll be repeating the process of DES 3 times. Okay. So the size of key will be eventually it will be increased in in double DES and triple DES, as I already told you. In double DES it will be 112 bits, and in triple DES it will be 168 bits, right? So as the size of key increases, then the security of the algorithm will obviously increase. Fine. So that is all for today. So today we will discuss the last two parts of DES, which is multiple DES and the security of DES. Okay, so about multiple DES, I told you that we can use 2 DES, which is called double DES, and 3 DES, which is called triple DES. Right. So why these multiple DES were introduced? Because of the length of key in the original DES was short. Okay. As per the critics of DES, it was just of 56 bits. Okay. So we can double or triple the size of DES key by using it 2 times or 3 times. Okay, so whenever we use this whole process of DES 2 times, we call it DES, and whenever we use the process of DES 3 times, we call it triple DES. And in triple DES, we have two flavors further, wherein in one type we make use of 2 keys only, but 3 times, and in second type we make use of 3 different keys, right? So we'll be discussing about it now. This is about groups, which says that since DES is not a group, that is why we can double or triple the DES, the process of DES, to increase the key size, right? So group is something which could map all the inputs to the all the inputs to some other outputs, right? So we need not to go into detail of it very much, but the thing which we need to understand is we can double or triple the process or the algorithm itself, just to increase the size of the key, right? So DES, this double DES, the idea behind introducing double DES uh, was to make this algorithm more secure. Okay, so it was assumed that the DES, after this improvement, after applying it 2 times, it would be vulnerable to to 2 raised to 100 12 times, right? But there is one kind of attack, which is meet in the middle attack, which proved that the double DES, it improves its vulnerability only to 2 raised to 57 tests, right? It does not improve its vulnerability to 2 raised to 112 times. So that was the assumption which was used to used before making use of 2DES, which was failed, right? Just because of this kind of attack. So that is why 3DES was introduced, wherein we could repeat the process of DES 3 times. So this is the diagram of DES, double DES actually, wherein you can see that we are making use of DES process 2 times over here, right? And this middle text has to be same over here and here. So this kind of structure we also discussed in one of the previous lecture, wherein we compared, or we checked whether this middle text over here and over here, whether they are equal or not, whether they are similar or not, right? So this is the structure of double DES. Next, we have this triple DES. I told you that triple DES is of we have 2 kinds of it. One kind make use of 2 keys, and it repeats 1 key. So here we can see that it is making use of this K1 2 times, right? And this K2 is being used only 1 time. So in the first step, in the first DES, it ciphers it, then reverse ciphering is done, and then again ciphering is done, right? And at the decryption side, the process is inversed, it is reversed. So here we'll be using this reverse cipher 2 times and the normal cipher 1 time. So that is the triple DES with the 2 keys. Just like this, we can have triple DES with 3 keys as well, which makes use of K1, K2 and K3. So in that case, this reverse cipher will not be there. There will be the simple cipher process, right? So that is about triple DES. So that is the same thing. Okay. So the possibility of plain text attacks on triple DES with 2 keys has enticed some applications to use triple DES with the 3 keys. So it depends on the application whether you want to go with this triple DES with 2 keys or with 3 keys, right? So we can we use this triple DES for this application, which is called pretty good privacy, which is this PGP application. Okay, so we make use of this triple DES for this kind of application. Okay, next comes the last part of DES, which is the security of DES, wherein we will discuss that whether DES will be secure, will be a secure option against the most familiar attacks which could happen on the data. So these attacks we will be discussing. First one is brute force attack, then differential cryptanalysis, which is this chosen plain text attack, which we discussed in the initial classes. Then the linear cryptanalysis, which is non plain text attack. So brute force attack, if we talk about the standard structure of DES, okay, which does not use multiple DES, so that is prone to brute force attack. Okay, because DES can be broken using only 2 raised to 55 encryptions. So that is why the concept of multiple DES was introduced, so that it can be saved from brute force attacks. Right, next kind of attack which it can face is the differential cryptanalysis. So it has been revealed that the designers of DES already knew about this type of attack, and that is why these S boxes and 16 rounds were included. When DES was introduced, these things were included beforehand. Okay, just to save it from differential cryptanalysis. Right, so we can say that DES, whether it is multiple or not, it is safe from differential cryptanalysis. Next is linear cryptanalysis. So linear cryptanalysis is it was not known when DES was introduced. Okay, so DES is more vulnerable to linear cryptanalysis than to differential cryptanalysis. Okay, so use of S boxes and using multiple rounds cannot save DES from linear cryptanalysis. So it has been shown that DES can be broken using 2 raised to 43 pairs of the known plain text. Okay, because this is known plain text attack. So, but finding this much pair of known plain text is not feasible actually practically. So we can say that DES is safe from linear cryptanalysis as well. Okay, so that is why this idea of DES emerged as a very good algorithm for encrypting the message.